Hello everybody and welcome to Drunk Science episode whatever it is. We are coming to you today from Illinois where I'm visiting some friends of mine and we are drinking the abysmal Mike's Hard Lemonade, but you know, it does the job. It essentially is just a glorified wine cooler, but I finished all my whiskey already, so what are you gonna do?
I'm sorry, I still works for me.
And I have with me a guest star. We have my friend Russell. Just there you go.
Hello.
Hey.
Can you do that?
Hello, welcome to TV land. So today we are going to be talking about a specific type of chemical reaction called an oxidation reduction reaction, or shortened to redox. It's a terrible name for it. We'll get to that later. So, as many of you are aware, there are three parts to the atom. There is the protons, the neutrons, and the electrons. We're going to be talking about the electrons. Now, a lot of chemical reactions are based on the movement of electrons. Electrons are jumping from one atom to another. You know, some atoms are gaining electrons, some atoms are losing electrons. They're forming new bonds, they're breaking bonds. That's a lot of it right there. So, how do we quantify, qualify all those various interactions? Well, that's where redox comes in. Now let's look at that. Oxidation, reduction, two separate terms. They describe two separate behaviors. So, like I said, they're horribly named. For example, hey, cheers.
Cheers, mate.
Hey! Oxidation does not necessarily involve oxygen. It often does, but not all the time. Oxidation is any time a substance is losing an electron. Alright? So, say you have a sodium atom that is reacting with a chlorine atom to form table salt sodium chloride. The sodium atom is losing an electron and developing a plus charge. That is oxidation. 1 second.
Please don't edit that out.
I am recording directly in front of the bathroom, so I had to wait for somebody to go by.
I really hope the sound of a flush.
If you hear the sound of a flush, it's nothing to be alarmed of. So, yes, the sodium atom is being oxidized because it is losing an electron. By the same token, the chlorine atom is being reduced, which is again a terrible name because you're gaining an electron, you're increasing the number, but it's being reduced because it is gaining an electron. It is, however, adding a negative charge, so it's reducing the overall number of the charge. So I can kind of see where that's going. Some scientists have offered alternative names for these interactions, but you know, they don't really stick. Because in science, once we've been using something for a long time, he took my hat, we kind of like to stick with it. So redox reactions, it stays. Some things that you might be familiar with as far as redox reactions, combustion, right? You have a hydrocarbon fuel, usually a hydrocarbon at least, plus oxygen gas, O2, and then you're yielding carbon dioxide and water vapor. That is a redox reaction. That is just the movement of electrons. Yes, Russ?
I just want to point out that when I was in high school chemistry, this was a section that destroyed me. So I'm glad that you explained it to people. Like, I went from an A to a D because of this.
It is a fairly difficult concept to understand, despite it being oddly simple on its face. But
especially when your teacher doesn't speak English.
That does kind of hurt.
What the hell is a skeletal system?
Skeletal system?
Yes, that's what I had to deal with.
That sounds like something to do with a Supreme Court justice.
Yes.
Antonin Skeletal. That's not his real name. But anyway, so another redox reaction that theoretically we will be able to add a video of is a really fun one that is popularized by a couple of episodes of Mythbusters, the Hindenburg episode, and then another episode where they make like a half ton of this stuff, is called Thermite. Thermite is brilliant, it is fun, it's also incredibly dangerous. So incredibly dangerous. And very, very fun. Cheers. Yes. My computer went to sleep. All right.
Buddy.
Right? So, thermite is a combination of aluminum powder and iron 3 oxide, Fe2O3, which is essentially rust. It's a very pure form of rust, right? As opposed to Russ,
Hello.
who is brown instead of red. But
And trying to think of viable additions to making this video, except
you're fine, dude.
Okay, cool.
Okay, but thermite is very interesting because what happens is you have the reduction of iron, because iron is going from a +3 charge, you know, each iron atom is short 3 electrons, it's regaining the 3 electrons. It's going from a +3 charge to a neutral charge, and then the aluminum is going to a +2 charge, I believe.
Yes.
I believe it is +2. No, it is not.
No.
I think aluminum is also going to a +3. Either way, the oxygen is changing over from the iron to the aluminum, and it does this under the presence of a source of extreme heat. The reaction that I usually do involves potassium permanganate, which is a strong oxidizer, and glycerin. The more common way of doing it is using a wick of magnesium metal, because that burns at an incredibly high temperature. But it's kind of like any other fire. Once you get it going, it kind of just keeps itself going, but you have to have that initial spark of heat.
You should continue drinking.
I should continue. Okay.
You sound like you're thirsty.
Fair enough.
That was a sip.
Shut up. But anyway, you have the formation of pure iron, and this also produces a massive amount of heat. Each mole of thermite, each mole of the mixture produces 870 kilojoules, which is not a massive amount, atom by atom, but if you make, like, say, 40 grams of this stuff, it burns excuse me, hotter than molten lava. This burns incredibly hot. So you have a massive amount of heat, you have a massive amount of light, you get some sound as well, and then your end product is a molten pile of iron slag, which is really fun. I use that as a demonstration when I teach classes. But that's another really cool form of oxidation and reduction, which, again, really simple concept that kind of seems super difficult. Oxidation, losing an electron. Reduction, gaining an electron. Done and done. All right, but as always, subscribe if you like it. Let me know in the comments if there's a particular subject you would like me to see, or I guess a particular thing you would like to see me drink. And I'll see you next time, whenever that may be. You take care. Bye.